And now in the run the motor, we're going to set a true here. But we also probably want to make sure that this indicator is false. So I'm going to create a local variable and just make sure that in the previous state, which is waiting for button, that he gets set false. And then every loop he'll get set false again. So if that was a problem for this particular piece of hardware, whatever this is attached to, then we might need to deal with that. But it's just an indicator, so setting it false every cycle is going to be just fine. So the motor on goes to true, and so what we need to do is we need to start a timer. And so what I could do is I could say, okay, well, I'm going to start a timer when the first loop happens. But another thing that I could do, and again, is I could actually initialize my timer value here. And so what I can do then, in fact, if I wanted to be a purist about it, I can actually create a case structure off of the user button. And if that's true, then I'm going to grab the value of the millisecond timer, and then I'll actually go ahead. I'm going to hide this guy so it doesn't show up on the front panel. Create a local of that. So I'm just going to grab the value of the timer, because when we come into running motor, the millisecond timer, and in fact if I have questions about it, I could just do Control H and pull up my context help and see this is this just says the millisecond timer value, and I can go in here and read about that and learn that this is an integer number. So this is going to be a very, very big number, and so I need to take two of these guys and subtract them. So again, if I were to take the current value of the timer minus whatever the value was when I first recorded that start value, well, that's the motor timer. So I can actually create an indicator, motor on time, and that's going to be in milliseconds. And so if the motor has been on greater than the value of the motor timer, then we're done. Let's see, yeah, this is actually a U32, so I'll change that U32 to get rid of my coercion dot I had there. So now this is actually, here we go. So now case structure will be useful here because we're going to do more than just determine what cases are next. Let me get rid of the context help because that's a little confusing. It's just distracting over there. So let's see. I'm going to change the way I'm doing the motor LED. So let's say that if so what do we have here? If the timer is larger than this, this means we should stop the motor. So motor on should be set to false. Some code to so if I had some code to stop the motor, I'd want to put that here, and then I also need to figure out where I'm headed next. So if we've run long enough, then I'm going to go to the next case, and sure enough, from the spin the motor case, the state diagram tells us we should go back to the waiting for index pulse case. So then we got waiting for pulse, wire that guy up. If the motor hasn't been on longer than the timer, then we will say keep running the motor. If this were like a DC motor, for example, then I would not need to do anything, because when I would, I guess what I would need to do here is when I'm running is I will need to send some voltage out to the motor. So we'll say the motor on is set to true, and the next state, if I create a constant, will be right where I'm at. So motor running. And then finally, how do we get to the shutdown case? Well, I guess I need an exit button, so that's going to be one more thing. And in my buttons, sure enough, there's one called stop, so I can use that. my stop button. And so my stop button is in the waiting for index pulse case. And so I can just grab another select statement, is usually a nice simple way to do this, and say that if the stop button oops, that's not right. If the stop button is true, then I want to shut down. If the stop button is not true, well, then I want to do whatever was formerly done over there on index pulse. Setting the index, turns out I don't need this motor on anymore because I changed the way I was planning on doing motor on. It's either going to give you motor on or motor off here, depending. And then for my shutdown case, well, I'm going to come into shutdown, and I need to wire something up to my case selector, but when shutdown runs, I'm going to have this guy that's going to basically stop execution. So it's not going to run again, so the outgoing case of shutdown doesn't matter. So I'm going to create a constant here just so I can run the program, and it doesn't make any difference. I'll send it back into shutdown because, I don't know, seems a little bit safer that way perhaps. And then let's go to my front panel here, and let's see how we did. So let's say the motor will be on for 1 second, so 1,000 milliseconds. So if I hit run, well, I'm stuck in the init state, so something's wrong here. So let's debug this program and see what we got. So I come into init, and I should go straight into waiting for pulse, and I did not. And why is that? Oh, the problem is that I didn't actually wire this guy up, so that's a fairly silly mistake. So we're probably running okay, but I got to actually wire them up to get displayed. So let's try it again. So now it runs. Presumably it ran init. We're in waiting for pulse. We click, and now we're waiting for button. We're waiting for button. The motor counts up. Let's do that again. See the lights on while it's counting, and I've got a state machine that's running. And so this is nice. One of the problems is that the stop button doesn't do anything when I'm in the waiting for button case. So I actually have a problem. I can only exit when, so if in order to exit now, I'd have to run the motor for a second and then hit the stop button. That's not very good. And if I come over here and look at my my state machine, sure enough, I don't have a case that takes me from waiting for button into shutdown. So I can come over here and modify my well, that's not the prettiest thing in the world. Blame that on Microsoft PowerPoint. But anyway, I want to have a case here that says, okay, if the exit button is pressed, go from the waiting for button state. And so I can do that simply by, again, I'm going to need to change the mechanical action on my switch because I know that latching operations don't matter or won't let me execute. So I'm going to create a couple of locals here. In fact, I'm going to create two locals. One is I'm going to turn the stop button to false in the init state. That's a good startup initialization operation. And then the other one is that in the waiting for button state, I'm going to also add one more case of, well, if the stop button is true, then shut down. And if the stop button is false, then do whatever it is that we could have done before. And I've now updated my statement diagram, I've updated my code, and then sure enough, I should be able to, here I can index pulse, run, there's the motor running, that's good. I can exit from the index pulse case, I can exit from the button case, and I now have a nice state machine program in Labview.